Hello everyone, my name is A. Srinidhi. I'm studying in Kongonadu College of Engineering Technology and I am currently pursuing BE in Computer Science Engineering. I'm going to share my views on layers in OS. First, let us see what are the things we are going to explore in this. First, we will learn about structures of the operating system, then focusing on their layers and how they interact with each other. And understanding these layers is very important as it helps us to manage its hardware resources and provide sources or a platform for applications. Then we'll see what is operating system. An operating system OS it is a collection of software which manages hardware as well as provides services for the computer programs. It acts as an interface between the user and the computer hardware which helps us to execute of applications and ensure efficient resource management. Then we'll move about layered architecture. The layered architecture of an operating system divides its functionality into many different layers, and each layer has its own responsibilities, which is used for easier management, debugging, and enhancement. This structure helps in isolating changes and improving overall system stability. And next is the user interface layer, which is known as UIL. It is the topmost layer compared to all and it interacts directly with the user. It can be a command line interface or a graphical user interface, which layers manages user input and displays the information, making it essential for the user experience. It is basically a very easy tool for the users. And next is the system call interface. The system call interface acts as a bridge between user applications and the kernel. It provides set of APIs which allow programs to request services from the operating system such as file management, process control and ensuring secure access to resources which we saw in the functions of an operating system. And next we move to kernel layer. Kernel is very important as it is the core component of operating system which is responsible for managing hardware resources. It handles tasks such as memory management, process scheduling and device communication. Kernel operates at a lower level providing essential services to higher layers. And next is the device drivers. Device drivers are specialized programs which enable the operating system to communicate with hardware devices. They translate general OS commands into device specific operations, ensuring that hardware components operate smoothly and efficiently within the system. It acts as an external layer actually. And next we'll see what is memory management. The memory management it is a critical function of the operating system which is responsible for allocating and deallocating memory spaces which is needed by the applications. It ensures the optimal use of RAM. Optimal use of RAM means efficient use of RAM and it manages virtual memory and which prevents memory leaks contributing to overall system performance. Next is the process management. The process management layer it handles the creation, scheduling and termination of a process. It ensures that multiple applications can run simultaneously without interfering with each other. It does it can run multiple applications in a same time at a same time without others interfering with one another. And for that, we are using techniques like multitasking and synchronization to optimize the CPU usage. Optimize CPU usage is nothing but it is the efficient use of CPU or CPU utilization. And next is the file system management layer. The file system management layer organizes and maintains data on the storage devices. It provides a structured way to store, retrieve, and manage files, ensuring data integrity and also the security. This layer also handles permission and access control for files. And next, we move to the security and protection. Operating systems implement security measures to protect data and resources from unauthorized access. This includes user authentication, access controls, and encryption techniques, ensuring system integrity and user privacy is a fundamental responsibility of the OS. And the next one is file system management. The file system management layer organizes and maintains data on storage devices. It provides a structured way to store, retract, and manages files and ensuring data integrity and security among the files. And this layer also handles the permissions and access control for files. And next we move to the security and protection. Operating system implement security measures to protect data and resources from the unauthorized access, and this includes user authentication, access control, and encryption techniques. Ensuring system integrity and user privacy is a fundamental responsibility of the OS. Security and protection, it commonly access the user authentication, access controls, and some of the encryption techniques. And next, let us see about the process. Here we can see application program, and application program in the user mode, whereas the topmost layer is the user mode and bottom belongs to the kernel layer. Kernel layer is known as core component of the operating system. Here, next, all the application programs is driven into system drives. System services is driven into file systems, and it also indicates with the memory and IO device management. And one part is into process scheduling and another directly goes to hardware, whereas in one part it moves to process scheduling and then it moves to the hardware. Next, let us see about 6 layers as in the OS. See here, the spherical representation of OS layers is given, whereas layer 0 is the hardware, layer 1 belongs to CPU scheduling, layer 2 is memory management, layer 3 is the process management, layer 4 is the buffering for input and output, and layer 5 is the user programs. Here there are 6 layers, and 6 layers it is represented as pure, where layer 0 is the inner layer which denotes hardware, and as layer operating system we have seen in the previous slide, it is of 6 layers and each layer contributes to one. And what are the things we are going to see in this slide? Layer 1 is the hardware, layer 2 is the scheduling, layer 3 for the memory management, layer 4 for process management, layer 5 for IO buffer, and layer 6 for the user programs. This plays a major role in it. And next we move to the what are the structures we have seen in before. It is given here also. Kernel is the core component as it is the innermost. Next it turns for memory management, next for input and output, next file system management, and the last one is user interface. There are also many spherical representations involving in the layered system of OS. And next we'll see about the some of the applications in Linux for the operating system. See here, application, and application denotes in kernel core and substance, whereas application is also driven into generic drivers, and it again interact with generic architecture code, whereas architecture specific code contains bootstrap, memory, threads, timers, IRQS, system calls, platform drivers, etc., and all last to the hardware. And next is the microkernel. The microkernel operating system here it denotes as microkernel operating system. We have seen in the kernel part. Here last it is hardware and then basic IPC virtual memory scheduling, and all the application IPC drivers, Unix server and file servers are driven both commonly through applications. And next is the conclusion. In conclusion, we have seen what are the things we are understanding in this lecture. We have understood about the layers of operating system, which is essential for comprehending how computer functions work. And each layer has its own vital layer in ensuring operations, resource management, and user interaction. This layered approach enhances modularity and simplifies system development. And that's it. Thank you so much.